Guys, today I want to teach you about a reading strategy. And I know the first thing you might say is, why reading strategy in math class?
You could say it, so.
But this reading strategy goes
She doesn't
beyond
know how
just
to
reading strategy for math.
Right now, she's for learning person.
And it's sort of this, it's what I describe to be a technique of reading that everybody does, but they don't really talk about. And that's sort of a shame, because so much of being a good reader is asking the right questions while you're reading, rather than just being really fast and getting through the text as fast as you can. So there's a certain technique or a habit that good readers develop to be able to understand what they're reading in an effective way. And there's the same thing with trying to understand a word problem in math. So what I want to introduce you to today is what I call a think aloud technique. And it's going to be the questions I ask myself while I'm trying to solve a word problem. You'll see here on the board I have 3 statements, and let's start with a preview of them. First one says, what am I trying to find? That's a question I always ask myself whenever I'm looking at a written math problem. And you might say to yourself, well, what you're trying to find depends on the wording of the question. Well, does it? Because what the question asks me to find and what I'm able to understand the technique to find can sort of be 2 different things. So I sort of rely on my own understanding of what the question is asking, rather than looking exactly what the wording of the question asks for. Second question is, what type of calculation is required? And this is an important one, and it's one that's going to really specify how I follow my technique. And the last one is, what information do I need? So these are the 3 questions that I'm going to ask myself every time I'm approached with a word problem. And it's going to help me have a systematic approach to solving any type of word problem. All right, first one. Let's look at the word problem we want to solve. It's this one here. It says, now part of the read aloud technique is to always explain what thoughts are going in your mind, and always think about what exactly your mind is asking. And so to give you a clue of my thinking, whenever I see a word problem, the first thing I do is get a little panicked. Because word problems are not typical math problems, in the sense that a typical math problem is very structured, very organized. I have equal sign here, I have an operation sign here. I know exactly what to do, given like a template that I'm used to seeing. Word problems are kind of a little intimidating because everything's not laid out in a very systematic, easy to understand method. So the first thing I do is kind of panic. And how I calm my panic down is I just say, the first time I read it, I'm not going to read for perfect clarity. I'm just going to read to get a basic understanding of what information is available. So that's what I'm going to do the first time here. The statement says, in a clothing store, in a mall that rents space at $1.50 per square foot per month, the manager is planning a sale. All right, that was a lot of information. I don't know what's important. I don't know what I should remember, but I'm just going to move on. Normally, sweatshirts and jeans are priced and sold separately. Again, some information. I don't know if it's important. I'm just going to plow on. She will bundle the clothing as a set, selling 4 sweatshirts and 1 pair of jeans for $190. For 2 sweatshirts and 2 pairs of jeans for $140. Assuming the prices of clothes are fixed, what is the price of a pair of jeans? All right, that was a little exhausting. It's sort of a wordy problem and a lot of information there. But again, I'm not too concerned with specifics because I'm always going to go back and extract the important information. What I'm going to what I ask myself now is, what type of calculation is required? And for that one, to help answer that question, I always follow the same technique of going to the last sentence in my problem and seeing if there is any directions there that I can follow. So let's look at the last sentence here. It says, assuming the price of the clothes are fixed, that means the same, they don't change. What is the price of a pair of jeans? And that statement right there, that's a question that I'm going to have to answer. What is the price of a pair of jeans? Now, what type of question is that? What is X? That's algebra, right? That's the foundation of algebra. Given an equation, given one missing piece of information, what is that missing piece of information equal to? So what is X? Now, I sort of say, okay, it's an algebra question, but what type of calculation is required? I remember back to the question saying something about jeans, something about sweatshirts, that's two variables, and I think I remember two different situations, so two variables, two situations. That sounds to me like a systems of equations problem, where I have two variables, two equations. And so before I go back and extract any information, I sort of give myself a sigh of relief because I know exactly what type of calculation is required. It's going to be one that needs two equations and two variables. I'm going to set that up on the board for myself right now. Okay, let's go back reading the problem, try and extract what my two variables are and what my two equations will be equal to. That first statement there, does that contain any important information? Not really when I want to know the pair of jeans, because that's talking about square footage and what the manager does and what the rent per month is. That doesn't relate to jeans, so it's part of the question I could just strike out. As I scan around, I'm looking for sweatshirts and jeans in the same sentence. That's right here. And now I'm going to examine that sentence a little closer. She will bundle the clothing as a set, selling 4 sweatshirts and 1 pair of jeans. That's the key information. How many sweatshirts? 4. How many jeans? 1. And what is that price going to be? $190. All right, let's move on to the next statement. 2 sweatshirts and 2 pairs of jeans for $140. There's 2 X's and 2 Y's for $140. Now I look at my 2 equations that I'm now starting to build, and I see there's an important missing part. There is the operation. Well, let me go back to my reading to try and decipher what operation I'm going to need to use. And this word "and" is an important one, because 1 and 1 means 1 plus 1, so I think it means the same thing here. And thinking about what it's asking for, I'm going to agree that here "and" means addition. It's sweatshirt and jeans together, bundled, set, all those words let me know that I'm on the right track with this addition. Okay, that's where I'm going to stop right now, stop my reading, because I have a known technique I can use solving for systems of equations that I was able to successfully extract from a reading problem.